Can you see my screen?
Yes.
Yep. All right. Okay. So welcome everyone. Thank you guys for coming to the workshop. This is our first workshop where we will try to explain what really is blockchain. And yeah, apologize for the no webcam once again, but I'll get that fixed soon. So let's get right into it. Yeah, so for the sign-in form, if you guys could sign in, that would be really nice. Also, we just keep track of this just so we can kind of have like a roster of people who have attended every single workshop, and we'll get a better idea of like how many people we're getting and the faces that show up every time. So yeah, just sign up. Even if you're watching this on recording, just do it anyways, because we'll keep track of that and we'll potentially have some stuff in store in the future. So just quick reminder, in case you didn't go to the Genesis launch, Blockchain San Diego is our organization. The acronym is BASED, which is really fitting for crypto, and you'd probably learn in the future about it if you didn't hear about it already. Essentially, the organization is just a community of builders, researchers, and educators that just want to innovate on the blockchain, as well as educate people about it by growing the community here. So I think the overall gist of the whole organization for any newcomers is that we're all just big crypto enthusiasts that love to talk about blockchain, are passionate about the things that are happening in the industry, and we welcome everybody from every background to join us. This is just quick recap. Education is our kind of top priority right now. We want to host different workshop series to educate you guys about the different aspects of blockchain, as well as potentially do some blockchain development yourselves through our technical workshop series. And then by educating, we'll build and research. But you already heard that in the last event. So today we'll be starting our first series, which is Intro to Blockchain. And you can read the description right here, but essentially what this whole series entails is we want to give you a basis understanding in blockchain technology, but also all the things that concern cryptocurrency and blockchain, for instance, economics, as well as the technology behind it. So the goal of the whole workshop or the whole workshop series is to give you guys the foundational knowledge necessary for you to do exploration on your own. So we want you to be able to explore on your own and essentially be able to be self-learners or being self-taught. So the workshop structure will be on Zoom every single Wednesday from 7 to 8 p.m. But there might be some changes in the coming weeks because we are partnering with another school that wants to host workshops as well. So we might be doing like a every other week kind of structure, but you guys will have events to go to every Wednesday because we'll be hosting alongside them. So they'll be like taking over one workshop and we take over the next workshop. But we'll update all of that in the Discord. So be sure to join the Discord, bit.ly/basechat. And for the link for the Zoom, you can just use the same link every single time. And if you can't make it, do not have to worry. Everything will be recorded and we'll share it as we did with the previous event on the Discord. So the Discord is essentially the most important place to be because it's like the main communication channel between us and you guys. Any questions about that in general? You can put in the chat or just speak up. It's just the logistics of the workshop itself. All right, if we don't get any questions yet, we can move on to the content. All right, so before we even talk about anything remotely related to blockchain, we definitely want to talk about what's been happening in the space in the past decade and a half, or a decade, almost a decade and a half. So obviously, the biggest thing that has come out of the industry is Bitcoin, and most notably, the talking point of Bitcoin is its price appreciation. As you might have known, Bitcoin was below 1 cent at a certain point in time, and now I think this chart is a little outdated. Now it's back up to 57K or whatever, and it's definitely had some turmoil through its price action. So it ran up to 20K and then dumped back down, and then back up to 60K, dumped back down, now it's back up. So that's basically kind of the whole epitome of the whole space. Is just a roller coaster of emotions. The Bitcoin bubble, like I mentioned before, a lot of people call it a bubble. Even Jamie Dimon, CEO of a very big investment bank, and regardless, it just doesn't listen to anybody, and it just keeps on going and doing what it does. And I mean, people say it's a bubble, but we'll be discussing that in the future, and we're open to all types of discussions about crypto in general. Bitcoin has also been used for crime. So this is kind of what popped one of the bubbles in the past 10 years, is the rise of crime that involved Bitcoin. As you guys know, as you guys probably know, Silk Road is like a darknet website that basically took payment in cryptocurrency, specifically Bitcoin, to buy illegal substances or illegal items. So that was definitely one bad phase of Bitcoin, but it's definitely long gone because Silk Road is gone. So in addition to crime directly, there's also been a lot of pump and dumps, which are essentially scams as well, or it's definitely criminal, but it takes a form of kind of manipulating people more so than actually like directly selling illegal items. So you can probably see one of these every couple weeks, and it just wouldn't. Nobody really would bat an eye because it's very much a norm that's accepted in the whole industry by now. And there are more scandals. So Mt. Gox on the left here is just only the biggest exchange, Bitcoin exchange back in 2013 or 2014. And it essentially just went bankrupt and lost a lot of Bitcoin. And you probably remember earlier this year, the Doge debacle with Elon and him just shilling it all the time, which is definitely debatable, but it's conversation for another day. Oh, and also, yeah, the UC San Diego student. I'm not going to talk too much about that, but there's something that happened there, and he's facing some time in federal prison. But now we're here in 2021, towards the end of 2021, and there are just immense amount of work put into the crypto industry overall, and it is reflected in the number of projects that addresses different issues, different applications in the whole ecosystem. So for this, it's only for like the projects that are pictured here, it's only the Ethereum ecosystem, which is just one of the whole vast space of blockchains that exist. So there are other ecosystems as well, and even just Ethereum is this abundant. So it's definitely something to keep your eye on, and something exciting to do, because there's a lot of really smart people coming into the space for sure. The goal of our workshops, or especially this series, is we want to debunk the myths of crypto in general. You might be hearing a lot of different things about whether it's a scam, whether it's worthless, or it actually has substance. So we want to kind of address those concerns, address those understandings, but also lay the foundation for the technology and allow you to think about everything from first principles. So you know everything about the technology, then you can evaluate things later on. And then there are no prerequisites. It's just honestly just be open to the information that we're giving you, and you'll be good. So I'll pass it off to Chen right here to give you some really basic definitions that you should know in this space. And yeah, go for it, Chen.
Hi, my name is Chen. So after all this news, let's talk about some of the basic definitions of cryptocurrency and Bitcoin. So what is a cryptocurrency? So it is a digital currency not issued by any central authorities that can be used to buy goods and services. So unlike dollars or euros that were issued by the government or the banks, the digital currency is not issued by any central authority. And it was made secure with cryptography and consensus algorithms. So the Bitcoin is the most popular example of any cryptocurrency. So now one may wonder, what is the technology behind the cryptocurrency and what made Bitcoin possible? So it is blockchain. Blockchain is the data structure used to represent a cryptocurrency. It stores data in a way that allows multiple parties to access it reliably without having to trust one another. So basically, blockchain is a ledger, digital ledger, that is visible to every user in the same system and is immutable. Also, it has many infinite applications in social medias, healthcare, etc. So the question we need to ask is, what is the motivation to create such a new asset if you already have like dollars, euros? So to answer that question, we need to look at the problem that we face today. So there's over-reliance on banks and the government over our lives. So in the conventional currencies like dollars and euros, they were issued and printed by the government. So they have the ultimate control over the flow of money and the market. Also, another problem is zero transparency provided to the average consumer. So me as an average consumer, I don't have access to all the information about transactions that happens in the bank. And also, the last problem is that all the databases and networks are prone to getting hacked. So in the single source, in our conventional currency, there's a single source authority that stores all the data. So no matter how sophisticated is the protection or security, it is always a simple target. And this problem can be solved perfectly in cryptocurrencies. So the basic difference between cryptocurrency and conventional currency is the essential difference between decentralization and centralization. And a centralization system is a single party that has the concentrated authority and power, which is the same party that stores all the data. For example, some hierarchical organizations, political dictatorship, or even some big tech companies. And in the meme here, it portrays the system very well, since this the Marie Antoinette, and only I get to eat cakes. It's such a symbolize the centralized system. So there are some pros and cons of centralization. And the evident advantage of centralization is the efficiency. So since the data is stored in a single location, it can be accessed and manipulated quickly. For instance, the central bank can process thousands, if not tens of thousands transactions per second, which is virtually impossible for cryptocurrencies like Bitcoin. And also, a centralized system is flexible. Since there's only one party, a single entity, all the changes and updates can be approved quickly within the single entity. But also, of course, there are some disadvantages, some cons, which are the main motivation to create such a digital asset. So the first one is the single point of failure. In such a centralized system, if the central entity fails, the whole system fails. A clear example is when it's bankrupt, all the users are affected. And another one is the single point of control. So this central entity has full control of data that may use it however they may please. So on the other part, on the contrast, we have the decentralized system. This is where the authority is governed by many parties over a shared protocol. instead of one single source party. And the data is stored by multiple parties. For example, in pure democracy, the power is distributed among all the citizens. Also in the flat organizational hierarchy. So this is a new management system that is being adapted by a lot of recent companies, where the conventional pyramid structure is destroyed and the organization is basically flat. And the last example is peer-to-peer networking. This is the one of the basic structure of Bitcoin. So of course, there's pros and cons of decentralization. The pros are transparency. So the data is stored, it's shared among all parties of the system. Users know how their data was stored and used. So in the basic structure like blockchain, all the transactions are visible to all the users in the system. And also there's fault tolerance. So failure in a single party does not bring down the whole network because their power and the control is equally distributed to all users in the system. Therefore, a failure in one point does not affect the whole system. But there are also some disadvantage about this decentralized system. One of the most evident is inefficiency. So in the structure like blockchain, multiple parties must duplicate data, and there are extra computation to maintain the decentralization, because to maintain the security of a blockchain, often a lot of different entities work separately to solve the same cryptographic problem, and that is a waste of computational power. And also, this system is often inflexible because since the power to dictate is distributed among all parties. So to get any update or change in this system, it needs to get the approval of all the entities. So it is quite a disadvantage. Okay, now our friends Gunnar will dive deeply in the concept of Bitcoin and how it works. Thank you.
All right. Hey, I'm Kunal. I'll be taking over like how Bitcoin works. So Bitcoin is like the OG cryptocurrency, right? And it's like it was it came out of the 2008 crisis when all the banks defaulted and no one was held responsible. So this guy, okay, this is not the actual person. This was just like some guy who did they pick the guy with the same name in California. And yeah, they're like, oh, you created Bitcoin. He didn't really understand English that well, so he said, oh yeah, it is me. So this is not the guy. He just now, since it was like so became so popular, like they just put his face on it. No one knows who Satoshi Nakamoto is. That's the beauty of it, actually. Just pseudonymous people creating stuff. And so this so there's no third party, there's no bank, government for issuing like mining Bitcoins or like settling of any transactions. It all happens on the network between these nodes. And it uses cryptographic proof. So it's mathematically true. Like when you settle a transaction, it's mathematically the right transaction rather than, like trusting Chase Bank or something that it's the right transaction. Uh, let's dive deeper into this. Oh wait, yeah. Does anyone have any questions? Feel free to like unmute yourself and just ask questions. I won't bite. None? Okay, 5, 4, 3, 2, 1, go. Okay, let's go. Identity. What makes your identity truly yours? Okay, let's first cover hash functions because I feel like this is important. This is like the core of cryptography. Uh, it's like hash functions are like unique functions which take like any input, say like a string, a number, a picture, or even like I don't know, like 2 gigs of file. It all produces the same, say, like 12 characters. And It's in the form of hexadecimal encode. If you don't know like what hexadecimal is, it's basically like 1, 2, 3, 4, 5, 6, 7, 8, 9, and then like A, B, C, D, E, F. So it's like total of 16 characters. It's sort of similar to like a deck of cards with having like just the number cards and the high cards like Jack, King, Queen, but a bit more like longer. So the output of this function is usually called the hash or the digest. And the sole purpose of a hash function is to scramble the input into some unrecognizable output. This makes it like mathematically impossible to reverse it back. There's like no known algorithm to solve a hash function. Like the only way is to like brute forces, which means like trying out different stuff and checking if the input matches the output. And like if you put the different inputs, will your output match the desired hash? And so usually we use like 64 character hashes in hashing, because for a 64 character hash, it is like 16 to the power 64 options, right? Which is like 2 to the power 256. Which guesses are, it's like a really big number. And it's like, it's impossible to run, even if you like pool all your resources together, like pool all your computing resources on this planet. And I think it's like 140 million tera hashes or something, which is like all the computers on the Bitcoin network. And this is per second. It will still take like just billions of years and like billions of times like the actual age of the galaxy to find that one hash. So it's like incredibly secure. Yeah, so it's pretty unbreakable. Like I think there's like a video by the YouTube channel, three brown, one blue. Oh wait, three blue, one brown, which shows how difficult it is to break a 2 to the power 256 encryption. It's like the same encryption used in your text messages and like in your Facebook Messenger text messages, so that it's basically impossible to break them. Um, Also, you might think like these huge 2 gigs of files, how would they fit into a 64 character? Aren't you like losing some information there? But that's like the point of it. Like 2 to the power 256 is such a big number. Like there's like 0% chance if you take another file, it would like collide basically. Like it would like go to the same hash. And yeah, so this is how encryption works in everything like Facebook Messenger, Snapchat, Instagram, WeChat. Maybe not WeChat. I don't know. So it's impossible to like decipher your messages. You should like sleep, save, like, fine at night. Yeah. So let's go to the properties. Um, Deterministic, which basically means like getting the same identical output every time I give you the input. It's like saying if I input Kunal into the function and it gets some hash, if I input Kunal again tomorrow, it will give me the same hash. Like it's basically saying like 2 plus 2 is 4. It will keep staying 4. Sounds pretty basic, but it's kind of important in cryptography. Um, Collision resistance, that means that 2 hashes will never map to the same output. If Kunal inputs to a hash, Kunal's will not input the same one. So yeah, they'll be like completely different. That's like the avalanche effect. It's like I change one letter and it won't be like 0x43 and then 0x44. It would be like 0x43 and then I don't know 0x3 EF, something like that. Completely different. There's no like pattern matching. You can't like put it in an AI algorithm and see, oh, this is what this supposedly hash will be, and what the input will be. And pre-image resistance is basically the same thing. It's like there's no way of like breaking it from going from output to input. Like no one can do it, not even the smartest people, not even like NSA. So fast, that's important property. We'll go more deeper into it like in further workshops, but yeah, those are just examples. Just forks, just different strings outputting to completely different stuff. Should I? Uh, I'll show the ETH bill thing. It's give you a more clearer picture. Actually, wait. I need to share my screen. Wait, give me a second. Oh, those are different screens. I need to share in a different one. Or maybe wait. I can just put the tabs together. Wait a second. Okay. Let's put this here. Okay. Can you all see it? Like the hash function? Like
Yeah.
give me a thumbs up or something. Okay. All right. So you see there's like this text, right? Go Triton here. This Triton, go Triton. This is your hash. It gives you a string here. So this is your output of the function. I'm also like showing the color because it's easier to see a color change than a string change. And if you see there's a length at the bottom, it says string 66. So it's 64 plus the padding 0x. And let's say I change it to go Triton. And okay, the color didn't change much, but if I like do it like X or something, it's different. So there's like color changes completely every time you do it, which means the string is also changing because the color is sort of based on the string. So also you could have a file, but I won't show it right now. Just running a bit short on time. Let's go back. Okay. Okay. So this. Okay. So what does hashing lead us to? Public cryptography, and it's like it's basically coming back to the same question: what is your identity? Like, how do I know you are who you are saying you are, right? This is like the notion of public key cryptography. In the Bitcoin network, your wallet is your identity. It consists of a private key and a public key. The private key is your secret key, and the public key is, wait, the private key is your secret key, and it's like generated in the range of from like 1 to the power 2, 1 to 2 to the power 256 in like hexadecimal. So the same notation basically. And you derive your public key from your private key through like asymmetric encryption, which is just like a fancy way of saying just one-way functions, same thing as hashes. And in like Bitcoin, like electric curve cryptography is used, which is like super interesting, but I won't, it's like beyond the scope of this series. But I'll include like a link in the resources so that everyone can check it out. Only thing you need to know is like it's the same thing. It's not reversible. That's like the most crucial part. It's like if you're wait, next slide. Yeah, okay, you can go to the next slide. So it's like saying your public key and private key. It's like sort of your, if your public key is your mailbox, then the key to your mailbox is your private key, right? Everyone can see it, everyone can access the mailbox, they can like put stuff into the mailbox, but only you can like unlock it. So that's why like, so that's why it's like that's like the only way to unlock a wallet too is with like a private key. That's why it's like highly recommended to keep your private key in a safe place and not to share it with anyone. There are like multiple cases where people lose their private keys and like they get locked out of their wallets permanently. It makes it like impossible to like recover from that. And it's just like there's no like customer service or forget your password like options for private keys. A common like question people have is that there might be like overlaps in public keys, but it's the same thing, right? The public keys are generated in range of 2 to the power 160. So if you divide it by like 7.8 billion, it will still be like 2 to the power 126, which is still really big. There's like infinitely small chance that two keys might collide. So you can basically, which means like you could generate as many key wallets as you want, as many public private key pairs you can generate and like, I don't know, make a bot which auto generates addresses, still you won't find any overlaps. Yeah, I think this is like, it's more important like in digital signatures than like, like encryption here, but I think we can go over that later. Oh, I actually have another ETH build for it. Oh, I need to share it. Wait, I need to go back again. Let's see. The second one is key pairs. Okay, found it. Can you see it? So, you see there is this button, key pair. Oh, you can see it, right? Just give me like a nod or something. Okay, yeah, got it. So you have this button and you can like generate these wallets basically, like public, private key. Wallet is just a public and a private key. So I just generate another one. I get another hash. This is address. There's a public key, private key, and address is sort of hash from your public key. Thing is like you only need to remember your private key so that you can like, anytime if you forget your public one, you can just like rehash it, and it is deterministic, right? So it will keep generating the same thing. And so this is the digital signature I was talking about. Like once you have your wallet, you can like sign a message. This message is like basically like ERC is the best college. And there's the private key. You see there's the private key going here. I'll annotate. This is the private key, signing it, and then you get a string. This is your string. And this public key, this button is basically like just signing it, which I think it does it automatically anyway. So this is the important function. Like this is what makes it like really like stand out. Like it's like this recover function. It's like I can verify that you have signed this message, but I don't have access to your private key basically. And it's like, yeah, it's like contrast this to like opening an account, like a bank account, let's say, like Wells Fargo or something. You pick the worst one. And if you go to a bank, you have to submit a lot of identification documents, deposit money, and answer some silly security questions. What's your mother's maiden name or something? But after 2 days, only like your bank account is activated. This is like such an hassle compared to this. This takes like a second. And yeah, so you can digitally sign your signature, which is like the neat part. You only need to like recover or verify this message without having the public key. So this is what enables like blockchain, right? You put up a transaction, and everyone else who doesn't have access to your private key can still verify it, but it doesn't know, it still can't access your private key. I think that is it from this slide. Let's go back to screen sharing. Public key, private key. Oh, any questions? I feel like I went over a lot of stuff. Any like questions? How does this work?
There's a question in Zoom chat, Kunal.
Oh, okay. Is the private key a hash itself? No, it is picked randomly. Like every network has its own. I don't know if you've like studied CS enough, but like if in CS this, it's very hard to get us like actual random function. It's always like pseudo random because anything which generates random numbers is super slow. So if you use the same random function in here, it won't work because there's ways to game around it. Like you could like have the, if you're generating using the same timestamp, even timestamps can be like modeled with. So these are like true random functions, and they pick a number for you. So it's not a hash. The hash comes in when you like encrypt your uh, private key into a public key, if that explains it. Yeah, I don't see any more questions. Let's go over next. Transactions. Okay, once you know who you are, now you want to make transactions to people. I should present this. Oh wait, actually I'll get the last ETH build too, so that I have to transition again. Let's see the last one. Okay. Like this one. Delete this. Go back to the workshop and present. Should be smoother. Transactions, yes. Slide. Okay. I mean, like when someone says transactions, usually think of like bank transfers or like Venmoing money to your friends. But in like blockchain perspective, like the word transaction has a broader meaning. It's like an exchange of value between person A and person B. So it sounds kind of vague, but it's intended like that because value is not just like in money on cryptocurrency. It's also in like trading cards, collectibles, art pieces, or what we call like non-fungible tokens in crypto, or like even like law documents, medical data, anything which is like an interaction and can be like recorded can be considered a transaction. So just be open to what a transaction is. UTXOs, um, yeah, transferring money in like transactions in blockchain are very similar to like cash transactions or like piggybacks. Like I'm using the analogy here, like this is one way of making sure like you don't like double spend money. And they're like piggy banks. It's called like unspent transaction output or UTXOs, which are piggy bank like data structures containing Bitcoin, which can only be broken redeemed once. So if I need to send someone money, I need to like I need to like break it and then send it like in another like another piggy bank. Like if the number of Bitcoins needed, the Bitcoins is more than what's needed, the change is returned back to you. And uh, via new UTXO, it's the same when you go to like a Starbucks and want to make like if you're paying for a $3.5 latte, right? You pay $5 in cash and you get $1.5 back. You can't really like tear 70% of your bank note, $5 note, and give it to the cashier. User's wallet is just like the collection of UTXOs. Uh, it's like pretty much like a physical wallet, right? It's just like you put cash like $5, $10, $15, not $20 or something, right? So an example would be like if if you have these if you have these, say your wallet is the one on the left, you have 1 Bitcoin, you have 0.7 Bitcoin and 0.5 Bitcoin. These are three different piggy banks and they total up to 2.25 Bitcoins. And now you want to make a transaction of 1.5 Bitcoin and say, oh yeah, your public address is on the top and you want to make a transaction. What you end up doing is like you break all of them. Like it's like it's like digitally broken, like it's like unsecure in a way. So you put it and then you make another one with 1 Bitcoin and 0.7 Bitcoin so that 0.5 Bitcoin is returned. 0.25 Bitcoin is returned. Like, if like say Alice has like three UTXOs, three like piggy banks of having 1 Bitcoin each, and she needs to pay Bob 1.5 Bitcoin for something. She needs to basically you need like two Bitcoins, right? So you put these two piggy banks into the transaction. It will be checked. Oh, these transactions are valid. It has one Bitcoin each, and they are broken into 1.5 Bitcoin piggy bank and 0.5. The 1.5 is actually transferred over to Bob, and 0.5 is written back to Alex. It's like a very simplistic render of how transactions work, but it satisfies the, yeah, it's like it makes sure like you're not like I can't. It's not like order book model where I could like it's just like rewriting stuff. So this is what makes a transaction like valid. Uh, wait. Yeah. So these things are what is like proof of ownership, which is like digitally signing transactions, as I showed you earlier with ETH build. And then there's like availability of funds. So every transaction, like Bob is receiving two UTXOs, right? These two piggy banks. And he can like actually check what's inside them. Like there's one and there's one. So there's no way like like Alice has two Bitcoins. And now, like this is the third point is the important one. It's called popularly like double spending. How you solve this is like once you like give it away, you can't like take it back. Like there's only like you give it away and then like Bob can take like the transaction is confirmed. It's a bit nuanced. Like you needs to be on the longest chain and to make sure like your transaction is verified, but we'll go on this like in future workshops. Okay, this is like what an actual transaction looks like. It's like that's like the on the left hand side is the interface. Like this 97 confirmations is like how many blocks have been mined after that. So this will we also cover this later. This is like 0.095995. That's like $600 something paid, and you have timestamps. You have the size. You see, it's pretty small. Like it's meant to be like as data efficient as possible. And that fees, or you have to pay fees when you're making transactions. We'll go on about this later when we're covering like mining. And yeah, and this is like the actual code. In the actual code, if you see, there's no like to and from. It's like the to and from is only like a very high level layer, which which is required like for people to understand. So I think that's what we cover in transactions. I had like another ETH build, but like which you can actually pay me. There's like a QR code. Actually, I'll show that. This is the one. So if you see, there's like okay, this is sort of supposed to be like password, but I guess you can use this. Anyone can access it now. And you hash it, the same thing, right? There's a key pair. You get an address from this. You get a string. String is the same thing as hashing, like the private key. So uh, I was supposed to show you in like ethereum.org blockchain. This clicks and then you can like, so the neat thing is like, if you have your like wallet setup and stuff, you could like scan this code and you can like pay me money and then I can like check it here. So it's like proper peer-to-peer. And yeah, we can like test this out later, like how this actually works. Think, yeah, distributed ledger. Oh, does anyone have any questions? In the chat. Yeah, it's like super high level right now, so it takes a while to like unpack it, like how just discuss each moving part, and we'll have like more demos and stuff together. This is like the first workshop, right? So you're part of the very first workshop for based. Yeah, if there are no questions, I can like hand it off to Pan and she'll like talk about just distributed ledgers and how it all like comes together. Take it away, Pan.
Yeah, thanks, Kunal. That was sick. Sick presentation on transactions and identity, and I think the ETH build stuff is really neat too. But how does everything come together to answer the question of what is Bitcoin, right? That's kind of the thing that we want to figure out today. So we'll talk about distributed ledgers. So what actually is a blockchain? That is what we're going to answer in the next few slides, but bear in mind that it's definitely going to be a bit high level, and we're not going to dive deep into the details just yet, but we will definitely do that in the workshops upcoming. But simply put, a blockchain is essentially just a distributed database, and for those that know what databases are or have studied databases before, it's just a store of data essentially. But in the blockchain sense, it is distributed, and distributed kind of just means decentralized as well. So it's stored by many, many people. I think Chen mentioned before that decentralization is just data that is being stored by multiple parties instead of one single party, which the traditional system of finance, healthcare, and government are currently doing. They're storing everything in one place. But yeah, this is different. So distributed ledger is kind of a term that can be used interchangeably with blockchain. But to be honest, blockchains are built on distributed ledgers. That's kind of a more appropriate way to put it. And essentially, the distributed ledger is a technology that essentially powers the whole of the Bitcoin ecosystem. And each person, each party that we mentioned before with the decentralization, each party in the network essentially just talks to each other and does some computations on their own, but then shares the result of those computations, shares the data, and then helps each other validate the transactions. And the specifics of how they do this, what computations they do, and how they essentially come to consensus on what transactions to validate, we'll be exploring in the further workshops. But yeah, so we also just want to talk about briefly what the properties of blockchains are. So the things that we've talked about before kind of lead to these three properties. So immutability is that the validated records are irreversible and cannot be changed. I will talk about this in the next couple slides, but it relates really strongly to hashing that Kunal mentioned before. And distributed, as we said before, distributed is because it's decentralized. So multiple people have a copy of the data, not just one person. And then finally is trustless because the transactions can be checked by the nodes independently. And this is related to consensus, which is something that we're not going to discuss right now because it's a very complicated concept. But just remember that trustlessness, everything is able to be done trustlessly because of the consensus mechanism of these blockchains. So to answer the question of what is actually a blockchain, let's just actually break down the whole data structure itself. So a blockchain obviously is from I guess like the obvious definition is just a block or a chain of blocks, right? And obviously each block must have some properties to them. So the properties that blocks have are the three main ones that we really care about are the data, which is the data about the transaction, right? Like Kunal mentioned before, the unspent transaction outputs, the UTXOs, that's the data that is stored in these blocks. And then you combine all that data to create a hash. So essentially get all those unspent transaction outputs, all those transaction data, combine them, put them through a function, and you get a hexadecimal hash that you essentially just assign to this specific block. And then you also put the hash of the previous block onto that block, and it'll be more clear as to why we do that in a second. So the data, like we said before, it's unspent transaction outputs, and the hash, like we said before as well, it's just a hexadecimal number of different characters. And we want to emphasize that the hash of each block is specific to each block, right? Regardless of what information the block has, it's specific to that one block and it's unique. So you can't change it, or you can't change something in the block and not change the hash. Everything will result in a changing of the hash if you modify the block. So that's just the property of a hash itself. And then the previous block's hash, it'll come clear in a second. So why do we store the previous block's hash, right? As you can see in this diagram, we store the previous block's hash because it kind of creates a structure like a linked list if you studied computer science before, but it's essentially just a chain of blocks. And how do you achieve that chain of blocks is by storing the previous hash. So the first block does not have a previous hash because it's the first block. We usually call that the Genesis block, and that's why we call our first event the Genesis launch. The first block has a hash on its own, 1z8f. It's kind of an arbitrary number because the hash itself is actually a lot longer than that. But that's essentially a hash that is unique to block 1 itself. And then for block 2 also has a unique hash, but the previous hash of it is no longer 0. It's storing the hash of the block before. And as you can see, this kind of just forms a structure that we call blockchain, and it essentially just constitutes the whole data structure idea that we've been talking about. Why is this blockchain or this data structure, why does this create the properties that we mentioned before, right? We said it was immutable. Why is it immutable? So essentially a blockchain is immutable because if you change anything in a block, if you change any information about the unspent transaction outputs, the hash of the block will also change, regardless of how minute or big the change is. So even if you change a tiny decimal point, the hash will change completely. What happens when a hash changes? As you can see, the hash changed from the original hash to H62Y, which essentially just breaks the blockchain because the hash or the previous hash of block 3 no longer corresponds to block 2. And we essentially are able to discard that part of the blockchain. And if we go to the workshops ahead, we'll realize that the longest block is kept and the shortest block is discarded. So this blockchain is essentially considered faulty, and nobody will essentially take this data and consider it as true. So this blockchain is broken. Therefore, the immutability property kind of comes in the fact that you can't change anything in a blockchain without changing the hash. And as a result, you're unable to essentially make that transaction valid. And we'll kind of explain how they take hashing to the next level through the proof of work consensus algorithm we mentioned before. But essentially, in order to change the hash or in order to make the whole blockchain valid again, you have to change the hash of each block to essentially match, right? So you have to change the previous block's hash from block 3 to match the new hash that you got for block 2 if you change block 2. So a computer actually can do that quite quickly because you essentially just have to calculate the hash for like maybe a finite amount of blocks in order to make that blockchain valid. So in order to make the creation of blocks much more complicated or much harder, we employ this thing called proof of work, which in the high level, just think that it limits the block creation to be 10 minutes. So you can only create one block in 10 minutes. And that it employs some math, but we'll explain more about that math later. This is kind of talking about the second property of blockchains, that is, it is distributed. So we mentioned before that blockchains are decentralized. So no single entity controls the data of the whole blockchain. And in this picture, you can kind of just see that each person, each party in the network has a copy of the blockchain and they have it individually themselves. And essentially by having this copy, you're able to validate transactions. And you can kind of control what comes on the blockchain and what doesn't come onto the blockchain. So you can check with your neighbor that you guys have matching blockchains and the blockchains are valid. We'll explain about how you can essentially make a blockchain valid in the technical term later on, but this is kind of just a brief overview. We just wanted to give you a big picture of what the blockchain data structure is, and then eventually we'll dive deep into how each aspect of the data structure works. All right, now for a little thing that we want you guys to do. So we want you guys to just open up this website. It's metamask.io. It's the most popular crypto wallet in, I guess, in the industry. It's just a industry norm, I guess, for Ethereum and for other chains as well. But we want you guys to download this, create a wallet. This is going to give you that experience of like creating a public key for yourself. So the public key, like Kunal said, is a public identifier, but it's pseudonymous, but it's still public. And then the private key would be something that you have to keep safe, like write down on some paper and then keep it stored somewhere safe. So it just gives you a experience of creating that public private key pair, but also we'd want you to fill out the form. So we'll send out a form at the end of this event, so that you can put in your Discord username and then put in the address, the public key that you get from creating your wallet. And then that will kind of just let us keep this in a database. And for whenever we're doing like events or we're doing different activities, we are able to use your addresses and kind of connect to you through the blockchain directly and not having to talk to you on Discord. Thank you. So we're just right on time. Really appreciate you guys coming out, and also big ups to Kunal for making all the content. It was definitely very time consuming and it was very in depth. So hopefully you guys enjoyed that, and yeah, hopefully you guys come to the next workshop too, because we'll definitely go a lot deeper into the nitty gritty of the technology. Thank you guys. Also, if you have any questions, you can just put it in the chat or just speak up.
What's the link to the Google form for our Discord username and address?
I was gonna send it on the Discord, but I might as well just send it here so everyone gets it.
Yeah, send it here. Did anyone create their MetaMask wallets yet? There's
So
also like mnemonic, which is used with wallets. It's like, it's easier to remember than just arbitrary private key letters like 1IEXC or something.
yeah, like the mnemonics, like the words essentially just correspond to your private key. So they're like it is your private key. So don't give that to anyone. But it's just easy for humans.
Yeah, it's like thing with passwords, right? It's really hard, bad design. Like people can't